Again, any questions from Tuesday that people remember? Otherwise, maybe they'll come up again as we discuss things. Okay, as you remember, we were talking about the different types of drawings, the title sheet, the C for the civil, and a lot of the drawing set will be taken up by the architectural drawings, and especially the floor plan, right? The floor plan is probably the most important drawing because it conveys information about the layout of the spaces in the house or the building. So what's up on the screen again is figure 1.5 on page 9. This is a residential floor plan. I think I have this one on a PDF. I'll blow it up a little bit after the lecture here, but in this case you see that a lot of information about things aside from architectural are included in this particular drawing. So again, in a residential floor plan, you might have a variety of information conveyed on the architectural drawing. In this case, there's electrical fixtures and light switches and plumbing fixtures, right? Things that you wouldn't, in a larger, more complex commercial building, those would be on their separate sheets. But in this case, in a residential drawing, that those things are combined. So it really depends on the complexity of the information to be conveyed, and I'm sure to some extent on the style and the conventions in the architectural office that put the drawing together. So again, a floor plan, a horizontal section taken at about 4 feet above the finished floor elevation. So again, we're slicing the three-dimensional building horizontally and then looking down at it, turning 3 dimensions into 2 dimensions. Also in the architectural set, we will have an elevation, right? An elevation shows, in this case, the exterior features of the building. Here we're looking at the east elevation, so which means that we are looking at what would be the east facing side of the building. So we're actually looking in the opposite direction. We're looking west, but we're seeing the east side of the building, if that makes sense. And again, you see, I'll turn on my pointer, right? You see these elevations denoted. Probably easier to see in the textbook, figure 1.6 on page 10. Elevation of, in this case, the floor and the top of masonry, some details about the exterior finish materials. These numbers here are designations of column lines. And you see on the elevation below, in the textbook, you see column, what I'm assuming to be column lines as well, the 1, 2, 3, 4. So in this case, we'd want to start with the floor plan to get oriented in terms of the layout of the columns. But that's a good way in a larger structure of keeping track of where you are on the plan. Right, a section shows, as it says, the building cut apart, so we can see more detail about features that we would have difficulty understanding if we were looking strictly at a floor plan. Again, I'm guessing these are column line designations, column 1 and 1.3. In this case, This extra column here is probably there to support the stairwell. So probably if we looked at the whole building here, we would probably see the column spacing is greater than this between 1 and 1.3. I'm guessing this extra column here is here to support this stairwell. Good evening, Jose. Glad you made it. Right, and again.
Oh, sorry.
Go ahead. Sorry.
I was gonna say, where are you pointing to the extra column?
In the drawing here, and I'm just making I'm making an educated guess, but this number 1, I'm guessing is column line 1 something, right? If we were looking at it from the other direction, we would probably see the letters, right? Because there's usually a letter and a number that designates column lines.
Okay.
So this is column line 1. I'm going to guess that this 1.3 is an intermediate column, that the regular column spacing in this building is greater than this distance here.
Understood. Okay.
But this intermediate column here exists to support this stairwell. But again, if we saw this section in the context of the floor plan, we could tell that for sure. And I was going to show some later on, examples of drawings. Maybe if I get a chance over the break, I'll see if I can dig up where this section comes from. If not, we'll certainly see it later in the semester.
Okay, thank you.
So again, you see elevations here of finished floor elevations. And this must be the right, the ACC ceiling, probably the ceiling level in whatever it is over here on this side of the stairwell. This might be a hallway. So in this hallway, there's a 9-foot ceiling, right? That would be the difference between an elevation of 109 feet and 100 feet. Here's our finished floor elevation on the second floor, right? So the floor to floor elevation is 13 feet 6. And then again, the interior elevation, so that the dimension from finished floor to ceiling would be the difference between that, looks like 122 and 113. Right, so again, another 9-foot ceiling. So again, and here these details, right? We have a section and the section contains details. So again, this says 1/A-13. So if we looked at the complete drawing set here and went to drawing A13, we should see this as detail number 1. Does that make sense? So again, the drawings will often refer to each other in terms of, a plan showing a section and a section showing a detail. Right, again, here's a detailed drawing, right? We're blowing something up to a larger scale to convey information that would be difficult to show in a smaller scale drawing. Right, so this happens to be looks like a spring-loaded roof hatch. Drawings also contain schedules. Schedules would be a list of materials that are used in the construction. So in the architectural drawings, we are likely to find a door schedule or a window schedule or a room finish schedule, where a door schedule is going to, likely have a door number. You'll find that door number also on the plan, but the room fit or the door schedule will give you the dimensions and the type and more details about the door. Again, room finish schedule. You'll see example on it. They're probably on the next page. You'll see that. So again, room finish schedule may say, what the paint colors are, or what wall finishes are. It might be wallpaper, or what the cove is, what the ceiling height is, et cetera, et cetera. And a schedule in the structural plans may show sizing of columns or beams. Right, here's the door schedule. Again, this was figure 1.9 on page 12. So somewhere on the architectural sheets, you'll see the schedule. Schedule refers to a door number. So again, I would expect on the plan to find this door number. This type might correspond to something that's in the specifications, or you might have to look in the specifications to find out what that type means. And then you have size, thickness, material, et cetera, et cetera. In this case, the abbreviations are shown down below. Fire rating hardware, right? Whether it's hardware has to do with the doorknob or the doorknob and lock set and hinges and panic hardware, right? If it's an exterior door, it would have a what's called panic hardware, right? The horizontal bar that you push to open the door when you're exiting, right? This sort of thing would be contained in the hardware schedule. So again, depending on what trade you are, right, the carpenter is going to look at this and take off from this and know what material that he or she has to purchase, what kind of doors to buy. Again, here's an example of a room finish schedule. So again, I would expect on the plan to find these room numbers, probably find the same room number and room name. Right, here's the flooring is carpet, the base, right, base being the I think of it as a trim at the bottom of the wall, right? And my 100-year-old bungalow, I have wood trim. In this case, this is talking about a 4-inch vinyl base. And what is PT? PT is paint. Paint. ACT 2x2 acoustical ceiling tile. And the ceiling height. Remarked surface mounted. Oh, surface mounted pediment, right? It's probably I'm looking at the remarks here for this vestibule. It's probably a walk-off mat, which I was thinking we looked at that, but that was my 110 class in the fall. We walked through the H building at Triton and looked at the walk-off mats, but we haven't looked at anything in this class here. So again, a lot of information about how the rooms are finished on the room finish schedule. Again, depending on your part of the team, depending on your trade, you may or may not pay any attention to this, right? If you're the plumber or the electrician, you're probably not going to look at this, right? If you're the carpenter or the painter or the ceiling contractor, right? This stuff is going to be important to you. The uniform drawing system. Again, these are standards for presenting information in a set of drawings. Again, my guess would be a drawing project, a large commercial drawing project is likely to follow these standards. Probably less likely that a smaller residential project will follow these standards. But this, lays out how the drawing set is organized, how the sheets are organized, the schedules, conventions, abbreviations, et cetera, et cetera. Sorry, we saw earlier examples of blueprints and blue lines. I remember a blueprint was a reproduction of a drawing that was drawn by hand. Right nowadays, very few drawings are still done by hand. Most of them are done on some kind of CAD system, some kind of computer-aided design, or CAD or CADD, computer-aided drafting system. So in that case, the architect or the drafter or the CAD technician is using a piece of software to draw. And then those drawings can either be printed out or now probably what's more likely exchanged electronically. Again, where we seem to be, what I would say, dematerializing the process of drawings, right? We're going to electronic versions of things as opposed to, having big rolls of drawings all the time. This particular, this is figure 1.13 in the textbook. These gentlemen here are looking at a large screen that's showing it looks like in this case, a rendering, as opposed to printing that rendering out and looking at it on paper. Again, in my experience, I'm much more familiar with having things printed out and looking at physical drawings, but that's not the way things are going these days. Nowadays, things are done electronically, and you can mark up or make comments on a drawing set electronically and send that drawing with the comments back to somebody. Again, that's the way that we are collaborating these days, collaborating around, electronic images rather than physical drawings. Right, so they're going to claim that that's green because we're using less paper and using less printer ink to print all these things up. Yeah, that's probably the case, but old-fashioned guys like me are still used to having a paper drawing around. So I'm still getting used to this being the way that we convey information. So what does reading prints mean? Again, you have to, and that's what we're learning this semester, is to look at the information on a two-dimensional drawing and visualize or create a mental image. What does that, what information is that drawing conveying to you in 3 dimensions? How do I interpret all the lines and symbols and form a picture of what it is that I'm looking at or trying to build, right? We build things in 3 dimensions, but we convey the information in 2 dimensions. So part of the skill set that I need to help you develop is the ability to make that jump from 2 dimensions and to 3 dimensions in your mind, right? Look at a floor plan, look at an elevation, and think about what is it actually going to mean when that gets turned into 3 dimensions. Certainly, any sort of tradesperson has to have that skill, right? You're going to look at a 2-dimensional drawing. Then you have to figure out, okay, I'm going to run my piece of conduit from here to here, and it's going to be about this long, and it's got to get bent here, or I'm going to put a junction box here, right? I mean, those are the skills that you'll develop or will need to develop in the field to successfully move from 2 dimensions to 3 dimensions. I don't know. I always never write on prints. I don't know. Again, I'm used to taking a set of drawings and having 3 or 4 different colors of highlighters and highlighting again, I'm a mechanical engineer, right? So I'm used to highlighting different surfaces with different color highlighters so I can see what's going on, right? That's what I'm used to doing. That's maybe not what people do these days, but that's the way that that was the process that I used to visualize what's going on. Okay, any questions? Okay, I am going to, let's find it here. Okay, let me see if I can get this to work here. I'm just going to put up a couple drawings. This one is called the Sullivan. I believe these are in your set of paper drawings. Remember, your textbook came in 2 pieces, right? You have the textbook itself, and then you have another folder of drawings. So I'm pretty sure you'll find this one in your set of drawings. Yeah, I have them both, the paper set and the PDF version of them. So I'm just going to show you a couple things here just to get you more familiar with what a set of documents looks like. So in this case, the Sullivan is a residence. It's a house. So being a residence, we're probably going to find the information a little more consolidated, a little more information on single sheets than we might find otherwise. Again, on our sheet number 1, we're already seeing front and rear elevations. Keys to material. Let me see if I can zoom in here a little bit. I always do that, sorry. Right, this, okay, I turn my, let's try that again. I highlighted the entire sheet in my PDF, sorry about that. Again, in this case, you're seeing on this first drawing, you're seeing general notes. It may be that this set of construction documents doesn't have specifications. The specifications may in fact be these things here, but here's some general notes. Design load, right? What we structurally we're designing the. Okay. Let me stop and start this again. Hold on. Oops, I threw away my Sullivan. We'll try it again, Jaquan, and see if this works for you. Again, otherwise, if you have the screen is green, that's not what I want the screen to be. Hopefully, the screen is showing the sheet number 1 of the Sullivan. I'm hoping that's what you're all seeing.
Yeah.
Okay, good. I'm not totally losing my mind, which is a good thing. So let's just look at some of the things that are happening on this drawing. I'm blowing it up a little bit. Right, we see right, general notes. Home plan is designed in compliance with the 2009 International Residential Code. Right, here's our I code, or our, again, IRC. Right, design loads show what assumptions were made in terms of 40 PSF. PSF means pounds per square foot. So that would be the live load. Live load means the load of the people and the fixtures and the furnishings on the first floor. Dead load refers to the load of the building and the structure itself. Maximum deflection limits. Remember last week we were looking, or maybe it was on Tuesday, we were looking at the span tables for the wooden I-beams, and they had span tables that were 3 different span tables depending on the deflection of the floor. So L divided by 360, I'll have to look up exactly what that means. I will do that and give you some more information about what deflection limit, what that means. I mean, in easy terms, it means how much give there is in the floor. But I will look that up for next time. Notes. Right. A lot of times you'll see contractor is to do something. So typically the architect is going to put a lot of responsibility on the contractor to, in this case, make sure that the soil and site conditions are in accordance with IRC 401. IRC is going to be our International Residential Code. Soils testing is not the responsibility of the designer. So you, Mr. or Ms. Contractor, might have to do some soil testing to make sure that the soil is what the architect thought it was, whether it'll actually support the building we're talking about. Soil well drained, right? Minimum bearing capacity of the soil, 2,000 pounds per square foot. So again, if you were the contractor and you were a little uncertain about the local soil conditions, you might have to go out and hire someone or do a soil boring. What else do we see here? Strength of the concrete. Verify depth of the frost footings with the local code, right? So in Chicago frost line depth is 42 inches, right? It means that that footing has to be, or this footing over here has got to be 42 inches below the grade to prevent us from getting frost heave. Let's see what else. Framing members. Here's glue lam beams, LVL, right? So a lot of information is being conveyed in this particular drawing. Right, remember I said that oftentimes plans will have symbols that indicate sections and details. Again, in this drawing, they're telling you what the convention is. So when we look here, we'll see if we can find that stuff. Right, so here's a building section, a section detail, a key of materials. Right, here's an east elevation. We have some dimensions shown, but by and large, we would have to scale off this drawing, or the floor plan will show those same dimensions. A lot of notes about what the exterior of the building is going to look like. This little triangle over here is telling you the roof pitch. Of the garage door. We'd have to look on the one of the side elevations to get the roof pitch of the main house. Here's the rear elevation. Uh, 7'10". Yes, that is correct. This is saying 7'10" from the top of the footing to the top of the foundation. I'm not sure how the top of the footing relates to the basement floor elevation, so that may or may not be the finished height of the basement. We have to look a little more carefully. But that's a good question. Right, here's the first floor, and it says, what, 8'1" 1/8 from floor to underside of the structure. Here's actually the place that will look. Section A on sheet 5. So actually we'll go there and see what that tells us about these various heights. That was a good question. I think that's Ayana asked. So we'll go to, we'll jump to sheet 5 and see what it tells us. Voila, there's a section on sheet 5. Let's just double check. Sheet 1. Yeah, section A on sheet 5. So we're going to go to sheet 5 and look for section A. Again, this is probably far simpler for you to do who have your paper copies handy than it is for me to flip through things electronically. Okay, so here's section A on sheet 5, and if I can zoom in over there, it's not actually telling me. It's an elevation. Actually, if I wanted to know now the height of the basement, and the height of the first floor. Since this is 3/4 scale, I would just put my scale on there and I would measure that dimension. That would tell me whether the basement floor is 7'10" or it's something different. I'm going to guess it's a little less because that 7'10" or 7'11" dimension was from the top of the footing, and you see that we're at least 4 inches above that because we have a 4-inch floor slab that's on top of footing. But again, this should tell us exactly the height of the basement and the height of the first floor. Right? It's not dimensioned, but we should be able to read it off the scale.
Can I ask a
Here's,
quick follow-up question to that?
sure, of course.
So when you were measuring with the scale, would you use the gap that's in between there? Does that matter, or do you include that when you're putting the scale on there? Does that make sense what I'm asking?
Um,
You see the gap between I guess that is the insulation. I'm looking at the basement as just an example.
yep.
So you see where it's waterproof below grade, and
Yes.
and then there's a gap in between the drawing. Yeah, exactly. Do you include that?
Okay, then that probably indicates to me that you are correct. This is not going to be the right height because there's a break in there. So yeah, good catch. Yeah, so I would not, in this case, that is not going to be not necessarily going to be the basement height because there's a break there. Yeah, I didn't see that. So you are correct. So we'll have to find the basement ceiling height someplace else. We're not going to see it on this detail.
Okay. Thank
Oh, you're very welcome. No, good set of eyes. Yeah, I was just trying to tie the indication of section on sheet 1 to the actual section on sheet 5. Let's see what we have. Anything else here? And
I think it's on sheet 2.
okay.
Interrupt. I think it is 7 foot 10 inches.
Yeah, there's probably a note someplace. Again, we'll be doing this again in a couple of weeks because once we get to residential floor plans, we'll have activities where we have to read all this stuff up. Yes, I see 7'10" here but again, that's from top of footing to top of foundation. We'll have to find someplace what the height of the basement is. I'm guessing it'll be on a note someplace.
Okay.
Right, so there's a basement floor plan on sheet number 2. And here's our first floor plan on sheet number 3. I don't see any indications of sections or details other than we have this stair detail. And that actually looks like the detail of the stairs going down to the basement. Just for kicks, let's see what. Yeah, again, I don't see any other sections or details called out here. lot of notes. Again, we're seeing a lot of things on the same plan, right? Seeing the plumbing and the electrical and some structural details all shown on the same plan. Remember I said that if it's a residence or a house, you can probably get away with that. But in a more complex building, that would be too much information to convey on one sheet. It would get too busy. All those things that weren't dimensioned on the front elevation, we can get those dimensions here. Right, here's the outside wall, the center line of the windows. Right, if we refer back now to the front elevation, everything about the front elevation, all the dimensions for the front elevation should come from this first floor plan here. Let's see what we see on sheet number 4. Roof plan. I'm guessing this truss profiles has to do with the framing of the roof. I'm just curious where the ABC comes from. Let's go back and see if we can figure that out. Yeah, 6 and 12 would be the slope or pitch of the roof. That is correct, Nick. Yeah, you see the main roof has a 6 and 12 pitch. This truss profile C, which I'm guessing is the garage, has a more steeply pitched roof, as does this guy here. Just for shucks, let's go back and see if we can find what that ABCD means. I don't see that, but I'm guessing we will get into that. Again, we'll be digging into the same set of plans here in a couple weeks. I just wanted to give you a sense of, we just talked about organization of drawings. I wanted to give you a sense of what a set of drawings look like. So let's grab one more set here. Sorry. Again, we'll see this one. This is Del High. Again, these paper drawings should be in the in your folder. Again, we'll do this one in more detail later in the semester. I just wanted to highlight a couple things here. Again, on the first set of drawings, an awful lot of notes related to exterior details. So this would be a lot of things related to civil. You see a little map up top here showing the location of the site, right? Site. But this stuff here all seems to look like exterior civil details. Sorry. Again, here is a civil plan. Right, we see some grade lines, just like a topographic map. These little X out are probably things that need to be demolished. Right, we're going to demolish these features on the site. Before we build the new structure. It says existing conditions demolition plan. Here is our somewhat stylized north arrow. Oops. Here is a plan of the site, so we see the building itself and the parking around it. And this looks like some other buildings that are being built as well. Let's just zoom in and see what we see. FF equals this. This would be the finished floor elevation. And you see elevations of lots of other features. I'm guessing somewhere there'll be a reference mark, right? What's the, what are we referring to? But in this particular plan, I see, again, a lot of things with numbers, 872, 870. I'm going to guess those are elevations of various features. Right, we have a slight depression here for this drain tile, below the general level of the parking lot. And the building is what? Building is what, 2.5, a little over 2 feet higher than the parking lot, which is good. Let's look at the plan itself. And again, I know I'm buzzing through this stuff quickly. I'm just trying to give you a, kind of a high-level view. This is like coming attractions because we'll be delving into this, again, this particular drawing in a lot more detail. Right, so here's our architectural set. Actually, this is almost like our title sheet. So you see an index of drawing, general notes, a call out of the members of the team. Here is, again, architectural. Here is a floor plan of a section of the building. Room names, room numbers, finishes. Here's interior elevations. Right, so we'll look at See if we find those on other sheets. Here's details. Here's details over here. And we should see those. We won't follow every set of numbers. But you see now where, okay, here's something else. Remember I talked about column lines. So over on the right here is this B, E, H. So this would be the column lines running in this direction. And we should also see column lines going in the opposite direction. Right? 9, 9.5, 4.9. Right? So in my mind, that would be column K 4.9. Right? That would be the column lines going this way and this way. And you see the column spacing and the structural spacing changes depending on where you are in the building. Let me just see. We'll look for a few other things here and then we'll take a break. I don't know if this is being helpful at all or if I'm going too quickly, but here's plans, mezzanine plan. Looks like a roof plan. Ceiling plan. Elevations. More elevations. Some interior elevations, right? Hopefully when we go back, I think we saw, just for kicks, let's see if we find that elevation again. Right, we should see reference to this elevation back on the floor plans. Here's a room finish schedule, a door schedule, right? All the things we just talked about, we're seeing them come together on this set of drawings. Oh, sorry, my page turner is very touchy here. Maybe look at that. Here's some additional details. Wall sections. Again, back to the plan, I would expect that we would see these wall sections. When we go back on the plan, we'll do that. Oops, come back here. Good question, Ayana. The architect or some member of the design team will typically be on site. They won't necessarily be there every day. The way the process works is that members of the team that are building during the bidding process, right? The architect puts these drawings out for bid. You know, they might have a pre-bid meeting, right? All the potential bidders might sit around the table, or nowadays they're probably on a Zoom call, and they may ask some general questions to try to get clarification. If the the architect may put out an addendum to the construction documents to address any questions that are raised during the pre-bid meetings in the bid process, right? Somebody finds something that needs clarification. The architect will typically issue an addendum. So on bid day, the contractors will be required to bid on the construction documents and all addenda. So it's up to the contractors to keep up with all the addenda that might be put out by the design team. When they go to build the building, the architect will likely be providing construction, what are called, some kind of construction services. Those construction services might include answering questions, but to a large extent, it's going to be the responsibility of the contractor to interpret the drawings. But if things aren't clear on the drawings, then the contractor or members of the contracting tier, we would submit or may submit something called an RFI, or a request for information. Right, if you're let's say you're the masonry contractor and it's your responsibility to build this wall, you're a subcontractor, you're in what's called the tier of contractors, right? So you might be the masonry contractor and you're a subcontractor to the, you're a sub to the general contractor. So you're going to send an RFI to the contractor, and the contractor is going to send the RFI up to the architect. And the architect's going to, or the RFI is going to say something like, hey, there's I don't understand this detail, or there's a conflict, or your intent is not clear, right? That's usually how these things are resolved. Again, the architect may or may not be hired to provide what's called construction services, right? Construction services would be to go out and observe and look around and see how things are progressing. But hopefully the process of addenda during bidding and RFIs, when the contractors all dive in, will answer questions, but inevitably, issues arise, and those issues, for the most part, will get worked out between the trades on the site. So again, this is still human beings working together to turn something in 2 dimensions into something in 3 dimensions. So it's as much of an art as it is a science. So hopefully that answers your question. Okay, we're a couple minutes after the top of the hour. Why don't we take 10 minutes or so break? So we will get going again at let's say 1/4 after.